Howdy. Right, this is video 6 and this is the one with two motors in it. I found out there's a bit of an issue of how I set up this circuit wizard file for you. You'll notice that the flowchart for challenge 6 is missing, so the first thing you're going to need to do is go and fix that. So the way to do that, make sure you've got challenge 6 circuit tab selected, right click on it, insert page, and choose from the drop down box flowchart. Make sure after current page is selected, and in here type in capital letter F flowchart semicolon and then IC in capitals 6. You've got to type it exactly like that, otherwise it won't associate with this chip. Click OK when you're done. Right, so now we should have a flowchart after challenge 6. If you do it exactly like I did there, it'll work out fine. Right, so for this one we've got to write a flowchart that's basically, it's going to control two motors as it says here. When I haven't pushed either of the two switches, I want these motors to both turn clockwise together. When I press the switch on the left, then one motor should turn anti-clockwise, one should turn clockwise. When I press just the switch on the right, the opposite of that should happen, and when I press both switches together, both motors should turn anti-clockwise. Now I'm just going to pause the video while I go and write the flowchart and then show you what it should do, and then I'll give you some tips on how to actually do it yourselves. Actually, before I do that, there's something else you need to do with setting up this flowchart page. I know it appears that time has just skipped there. Anyway, so once you go in, if you go and get like a digital box, you'll see it's a bit weird. It's missing all of the inputs. Same with the outputs. They're not all there as you would expect them from the last challenges. It's because the flowchart by default is set up for a different type of chip, one with less legs. So you'll need to change that if you go up to Project, Microcontroller, Program Settings, and from the list you need to choose the Genie E18. That's the type we use. You can see it's got more inputs and outputs. Don't worry about anything else, just click OK. Now when you go and look at these, they should have all of the 5 inputs you've got on the chip and all of the 8 outputs. Okay, right, again I'm going to pause it and then be very quickly back just while I show you what the flowchart should have done. Alright, so this is what the circuit should do, just to illustrate. Just before I show you, you'll need to do this with your setup to make it work. When you put a switch in, can you double click on it? First of all, give it a caption, so tell me if it's switch A or switch B so I can see when I'm pressing it. And then a really useful feature of Circuit Wizard is you can assign a keyboard letter to act as pushing the button. So this is switch A. I've used the letter A on my keyboard, and if I press A on the keyboard, you'll see, I don't know if you can hear me tapping, that has the effect of pressing that button. So do the same for switch B, give it a caption, maybe assign that to keyboard letter B. The reason you want to do that is at one point in this program you're going to have to press both switches together, and you can't do that with a mouse because you can only click on one at a time. But if they're assigned to keyboard letters, like so, you can press both or either one. Okay, so assign letters and name them. Also name your motors, motor A and motor B, so it's quite clear that when I test this, when I mark it, whichever one I press, I can see that it's having the desired effect. So if I press play, when neither push to make switch is pressed, both motors should turn clockwise. So here we go. And there they go, they're both turning clockwise. Hopefully this video hasn't slowed down so much that it doesn't look like that because of the frame rate. Anyway, so if push to make switch A is pressed, then motor A should turn counterclockwise and B should carry on going clockwise. It does, so they're doing opposite directions. If I flip that on its head and press B, I should now get B turning anti-clockwise and A turning clockwise. And if I press both switch A and B together, both motors go anti-clockwise. Okay, so you might think, well, that's great, you've just made a circuit that makes some motors spin backwards and forwards, but this is actually the basis of a lot of self-driving robot systems. So if you were to hook each of these motors up to either side of the robot, under normal conditions the robot might drive forward. If both of the switches, say, hit a wall at the same time, then you can see that that would have the effect of making the robot reverse away from the wall until the switches came undone, and then it would drive forward again. If, however, just one of the switches hit, say on the left hand side, then if you turn two motors in opposite directions on a robot, then it will spin on the spot, and this would have the effect of turning the robot and helping it to bounce and avoid its way off the wall. So if you then replaced, I don't know, these switches with, say, laser detectors or ultrasonic rangefinders like we've learned about already, then your robot can in theory detect the wall before it even collided with it, and it could steer to avoid it. Alright, so this is actually quite an important little circuit, and that's why I've got you to do it for one of your programs. Now, in terms of how you're going to get this to work, I'm going to show you just how to make one motor turn, and then it's going to be down to you really to figure this one out, because you should be using the knowledge you've learned in previous challenges about how to detect switches and how to detect motors to make this work. So I'm just going to pause it a second while I delete my flowchart. Alright, and I'm back again. So as I said, you're going to need the digital and the outputs command for this, a little bit different. Now, I've deliberately hidden all my connections because I want you to build your own circuit, but just to tell you, I've hooked up switch A to input 0, switch B to input 1. I've connected motor A to outputs 2 and 3, and motor B to outputs 0 and 1. You can pick whichever inputs and outputs you like, so long as you use them. Now, to show you the flowchart, then the basics would be, I'm just going to make a simple flowchart that if motor A is pressed, if switch A is pressed, motor A turns clockwise, turns anti-clockwise, and if it's not pressed, it turns clockwise. So it's basically going to change direction depending on whether the switch is pressed. This will be my help flowchart. So I know that motor A was hooked up to input 0, so I'm going to just set up a digital box. I'm going to go, is switch A pressed? Remember, caption your work because this will help me mark it and give you a better grade. And the two outputs I used for that motor were 2 and 3, these two here. Now a little note, this is all in the PowerPoint by the way. If you see how a typical motor driver's turned up, connected up, it uses two of the output chips on your PIC chip to control it. Now there's a bit of a rule here. If you turn one of these outputs on and the other one off, the motor will turn one direction. I think generally it's this way, so if I was to turn one on, the current will flow this way into the motor and back out, so it would turn clockwise I believe, and if I turn 0 on, the current will flow this way into the motor and it will turn anti-clockwise. There is a bit of a rule here. If you ever turn 0 and 1 on together, you'll actually cause the chip to blow up, because what you'll be doing is sending current in this way and current in that way, and you basically just made a giant short circuit by doing that, and you'll either blow up the driver chip or the PIC chip. But either way, the motor won't happen. So the rule is you either have both outputs off, one of the outputs on, but never both outputs on together to control the direction of a motor when using this type of chip. I hope that made a bit of sense. So just to show you it here in the flowchart, so I know I was using outputs 2 and 3, so I'm going to turn 2 on, but making sure 3 is off. Okay, and there we go. I'm just going to join that up. And what I'm going to do, I'm going to put in the no path here. I'm going to do the opposite. So if the switch isn't pressed, I'm going to turn on 3, but turn 2 off. And that should have the effect of all the time I'm not pressing the switch, the motor will turn one direction, all the time I am pressing the switch, it will turn the other. So let's go check that out. So it's just motor A. There we go, it's turning clockwise at the moment. If I press switch A, it turns anti-clockwise, and I can see that on the flowchart. Okay, I know it's a little bit slow, but you get the idea. Okay, now it's following, in a second it will follow the anti-clockwise path. It's just very slow. There we go. Okay, just to show you what happens if you turn on both outputs together. So this will be when I'm not pushing the switch. I'm going to turn on both outputs, press play. The program's still running, but you'll notice the motor's not turning. Now on Circuit Wizard that doesn't cause a problem, but in real life what would happening would be the little driver chip would be getting red hot right about now because you're making a giant short circuit through it. Alright, so remember, never turn on both outputs to the same motor together. Now for this you're going to have to scale it up for 2 motors, so you're going to need 2 of those H driver arrangements, You're going to need 2 motors, 2 switches, and then follow it as it did in the demonstration at the start. Okay, I hope that's enough. My last bit of advice is, remember, you're going to be doing a kind of, if this, is it this? If not, is it this? If not, is it this arrangement? So it's going to be a series of decisions going into one or another, but I'm going to leave you to work out the fine details. Okay, that's the end of video 6. You're doing really well if you've got this far.